All right, lesson 4, module 2 is we're still talking about adding integers on a number line, but it says efficiently add integers and other rational numbers. Remember, integers are positive and negative whole numbers, including 0. And rational numbers include these integers, but they also include fractions and decimals. And yeah, we're going to get there too. That's fractions, sorry, and decimals. Okay. So our first video here, stick with me, I know it's kind of long, but our first focus is going to be on adding integers with the same sign. All right, you get the idea there, even though I can't draw a straight line. Adding integers, same sign. Okay, so represent the sum of 3 plus 5 on the number line. So we start at 0, we go to 3, and then from 3, then we add 5. 1, 2, 3, 4, 5. And we end up at 8. Okay, again, it's totally okay if you had gone 1, 2, 3, then drew a vector over it. Ugh, but not that bad, sorry. And then from here, if you went 1, 2, 3, 4, 5, and then drew a vector over it. So this represents adding 3 plus 5. Easy enough. How long is the arrow that represents a 3? Well, I would think it's 3 units. What direction does it point? To the right. It's positive. How long is the arrow that represents 5? 5 units. Again, if you did the butt method, 1, 2, 3, 4, 5, or hop method, or whatever it is. In what direction is that one going? To the right. What is the sum? Now, the word sum means solution to addition problem. So on the number line, if I add 3 plus 5 together, I end up at 8. So the sum is 8. So if you were to represent the sum using an arrow, how long would the arrow be and what direction would it point? Well, I would go from 0 to 8. It would be 8 units to the right. Okay, so I know I'm going kind of quick through these guys, but it's just asking pretty basic questions about, what's happening on the number line. So what is the relationship between the arrow representing the number on the number line and the absolute value of the number? Well, the sum is 8, okay? The arrow is 8 units. The arrow's length is the absolute value. Right? It's 8 units. Distance from 0 is 8. So the arrow's length is the absolute value. Do you think that adding 2 positive numbers will always give you a greater positive number? Well, every time we add positive numbers, are we drawing arrows to the right? Okay. Sorry, be this way, be your right. I don't know. Anyway, on a number line, yeah, I do. I think it's always going to give us greater positive numbers. Why? Because both arrows are going to the right. And if you think of the number line, I'll come back here in a second, but if you think of the number line, if you keep drawing arrows to the right, you're going to keep getting bigger absolute or bigger positive numbers. All right, so now we're going to jump and we're going to do the same thing now, except the numbers are negative. Okay, so hopefully you got that part down. If not, pause and write it down. Represent the sum of -3 and -5 using arrows. All right. So I go from 0 to -3, and then I go from -3, 5 units left. 1, 2, 3, 4, 5. So if you remember that from the last lesson, the second digit, the absolute value tells us how far to go, and the sign tells us what direction. Well, how long is the arrow that represents the -3? 1, 2, 3. 3 units. What direction does it point? This time it's going to the left. How long is the arrow that represents the negative 5? 5 units. What direction does it point? Left. What's the sum? What's the solution to this addition problem? Looks like we're at negative 8. Kind of see something going on here? Seems like kind of the same questions, doesn't it? So if you were to represent the sum using an arrow, how long would the arrow be and what direction would it point? Well, if I go from 0 to where both arrows end up, looks like 1, 2, 3, 4, 5, 6, 7, 8. 8 units. So it's going to be 8 units long. And it's going to the left. Do you think that adding two negative numbers will always give you a smaller? Notice it's smaller because the further you head down the number line, the smaller they get. Well, if anytime I'm adding arrows to the left, they're going to keep getting smaller. There's nothing coming back towards the positive side. So do I think adding two negatives will always give you a smaller negative? Yes. Why? Well, both arrows keep going left. And if we go left, that's the smaller numbers on the number line. Left. So what do both examples have in common? Well, if you look at, remember what you just wrote down, the questions were the same, right? So the sums are both 8 units. Maybe instead of saying that, I should say the absolute values are both 8 units because they're not 8. One's negative 8 and one's negative 8. So I'll say same absolute value. Absolute value is distance from 0. Okay. So one of the sums was 8. Absolute value is 8. The other one was negative 8. Absolute value is still positive 8. They're both 8 units from different, 8 units from 0, but they're going in different directions. Which leads us to this nice little rule right here that we want to remember. If we add rational numbers, so any numbers, with the same sign, we add the absolute values and use the common sign. So if they're both positive, we add them together, answer's positive. If they're both negative, add them together, answer's negative. So I know we're going to keep going through a couple more pages here. Decide whether the sum will be positive or negative without actually calculating the sum. We don't have to. If I add a negative to a negative, if I go down the number line -4 and I go down 2 more, keep the common sign. The answer will be negative. Don't overthink it. Ugh, sorry, that's the word negative. I didn't write that very well. 5 plus 9? Well, you know what that is. That's 14. That's a positive number. So what will the sum be? Positive. -6 plus -3? Negative plus a negative. And I know we get that confused with multiplication. Negative times a negative is positive, but this isn't multiplying. This is adding. -6 plus -3. You're still going to be at that negative side of the number line. -1 plus -11. Negative. Ooh, what about 3 digits? Do we change the rules for 3 digits? If I add 3 and 5 and 7, no. We're still going to be on the positive side of the number line. Okay. About -20 plus -15? Negative. Okay. So now, sorry, I'm writing fast here. So now we can actually find the sum. Add them, keep the common sign. What's 15 plus 7? 22. I know that's what you're telling me, right? Okay. What positive or negative 22? Positive. Positive plus a positive is going to be positive. All right. -4 plus -16. Add the absolute values. So we add 4 plus 16. That's 20. If they're both negative, your answer is going to be negative. -18 plus 64. Add 18 and 64 together. Add their absolute values, distance from 0. 82, if I did that right. Negative plus a negative is going to be a negative. 205 plus 123, negative both of them. Add them together without the negative sign. They're absolute values. Negative plus negative. You go all the way down to 205, and then you go down another 123. You're at a negative 328. Same sign, okay? Don't overthink it. Follow your rule here. You add their absolute values, so drop the negatives, add them together, and then if they're both positive, they're positive. If they're both negative, then your solution is negative.